The experiment begins with an empty plastic bottle. A deflated balloon is also required for the demonstration. These materials are essential for illustrating the principles of gas expansion. The initial setup involves preparing the bottle and balloon for the next steps. Proper preparation ensures a clear and effective demonstration of the scientific concept. Begin by obtaining a deflated balloon and an empty plastic bottle. The balloon's flexibility is key to this demonstration. Carefully guide the deflated balloon through the bottle's opening. Ensure the entire balloon is positioned inside the bottle. The balloon should now reside completely within the confines of the empty plastic bottle. The process involves stretching the balloon's opening. The stretched opening is then carefully fitted over the bottle's neck. The goal is to create a tight seal between the balloon and the bottle. This seal is crucial for containing air or other gases within the bottle. A secure seal prevents leakage and maintains pressure. The integrity of the seal is essential for the experiment's success. The setup involves placing a balloon inside a rigid bottle. An attempt is made to inflate the balloon while it remains inside the bottle. Due to the confined space, the balloon's expansion is restricted. The air pressure inside the bottle prevents the balloon from inflating properly. The air inside the bottle exerts pressure in all directions. This internal air pressure acts against the balloon. The external pressure from the bottle's air counteracts the balloon's inflation. This balance of pressure prevents the balloon from expanding freely. The demonstration focuses on the successful removal of a balloon from inside a bottle. The balloon is now shown completely free from the bottle. This illustrates the completion of the balloon removal process. The balloon is no longer constrained by the bottle's shape or size. The demonstration highlights the method used to overcome the initial confinement. The final state shows the balloon in its unrestrained form, separate from the bottle. The balloon is inflated freely, without being confined within a bottle. This demonstrates the balloon's natural elasticity and capacity for expansion. The inflation process occurs easily and rapidly. This highlights the unconstrained nature of the balloon's expansion. The balloon expands to its full potential without external limitations. Observe the size of a balloon inflated outside of a bottle. Note the ease and extent of the balloon's expansion in open air. Contrast this with an attempt to inflate a balloon inside a bottle. Compare the limited inflation achieved inside the bottle to the inflation outside. Air molecules are in constant, random motion within a confined space. This simulation visualizes the free movement of air molecules inside an empty bottle. The molecules collide with each other and the walls of the container. This motion is due to the kinetic energy of the molecules. A seemingly empty bottle is, in reality, filled with air. Air, although invisible, is a form of matter and occupies space. The bottle's volume is entirely taken up by air molecules. This demonstrates that empty space is often filled with gases. The presence of air prevents other objects from simultaneously occupying the same space. Therefore, the bottle is not truly empty, but full of air. The demonstration illustrates the physical presence of air and its capacity to resist compression. A balloon is placed inside a bottle to visualize air resistance. As the balloon expands, it attempts to displace the air already occupying the bottle's volume. The air inside the bottle exerts a counterforce against the balloon's expansion. This counterforce is due to the air molecules colliding with the balloon's surface. The balloon's expansion is limited by the air's resistance, demonstrating air's tangible presence and physical properties. Air pressure is the force exerted by the weight of air above a given point. This force is exerted in all directions. Color gradients can visually represent the magnitude of air pressure. Deeper colors may indicate higher pressure. Lighter colors may indicate lower pressure. Visualizing air pressure helps understand its effects on objects and environments. The term empty space is often a misnomer, as it typically contains air. Air is a mixture of gases, primarily nitrogen and oxygen. These gases are composed of molecules that possess mass. Because air is made of matter with mass, it also occupies volume. Therefore, so-called empty space is, in reality, filled with air that has both mass and volume. The simulation illustrates air displacement within a closed system. A balloon is placed inside a bottle, representing a confined space. As the balloon inflates, it occupies more volume inside the bottle. The expansion of the balloon forces the air to be displaced. This demonstrates the principle that two objects cannot occupy the same space simultaneously. Balloons are typically made from elastic materials like latex or rubber. These materials possess the ability to stretch significantly under tension. When air is forced into a balloon, the internal pressure increases. This internal pressure exerts a force on the balloon's inner surface. The material responds by stretching and expanding to accommodate the increased volume. The elasticity of the material allows the balloon to inflate without tearing, up to a certain limit. Plastic bottles are engineered to possess a rigid structure. This rigidity ensures the bottle maintains a constant volume under normal conditions. The structural integrity prevents deformation or collapse when handled. Maintaining a constant volume is crucial for containing and dispensing liquids effectively. A balloon inside a bottle cannot inflate under specific conditions. Inflation is prevented when the air pressure inside the bottle is equal to the pressure applied to the balloon's exterior. This balance of pressure creates a state of equilibrium. The air inside the bottle resists the balloon's expansion. Therefore, the balloon remains uninflated due to this pressure equilibrium. The demonstration illustrates that air occupies space within a closed container. A balloon is placed inside a bottle, attempting to inflate it. The air already present inside the bottle has a specific volume. This existing air volume prevents the balloon from fully expanding. The balloon can only expand to the extent that it can compress or displace the air in the bottle. This visually confirms that air, although invisible, occupies a defined space. Air compression occurs when a force reduces the volume of air. This reduction in volume increases the air pressure. Attempting to inflate a balloon demonstrates air compression. As the balloon expands, air molecules inside become more compressed. This compression leads to a measurable increase in the internal air pressure of the balloon. The bottle contains air at atmospheric pressure. The air inside the bottle exerts pressure on the balloon. The bottle is not a vacuum. It is filled with air. The presence of air prevents the balloon from easily expanding. Molecules in a container are in constant, random motion. This motion is due to the kinetic energy of the molecules. The molecules collide with each other and the walls of the container. These collisions exert pressure on the container walls. Air is a form of matter, similar to solids and liquids. As matter, air occupies space. This property distinguishes air as a tangible substance. The space occupied by air can be demonstrated through various experiments. A balloon is stretched tightly over the opening of a bottle. The stretched balloon creates a seal around the bottle's rim. This seal effectively prevents air from escaping the bottle. The tightness of the seal is crucial for maintaining pressure. This demonstrates a simple method for creating an airtight closure. The air pressure inside the bottle exerts an outward force. The inflating balloon exerts an inward force, increasing the air pressure. When the balloon stops expanding, the inward and outward forces are equal. This equilibrium demonstrates balanced forces, resulting in a stable system. The experiment demonstrates that air occupies space. The presence of air inside the bottle restricts the balloon's expansion. The air inside the bottle exerts pressure. This pressure prevents the balloon from inflating fully within the bottle.